Hey guys, it's Mrs. Clancy. I'm here because we are going to be looking at um, a new section of our packets. I'm going to skip packet 6-7. Today we're going to learn how to graph exponential growth and decay functions and identify their equations and graphs. So it's really important that you have your packet, your calculator, and a writing tool. We have a lot of independent work today and discovery. So you're going to need packet 7, and we're going to skip packet 6-7, and we'll need a calculator and pencil. And for your homework, I just want you guys to complete 4 and 5 in the packet and then submit pictures of the pages via email or Remind. Make sure your name is on the top of each page, okay? So first things first is I want you guys to look at the first page, and I want you to make the graphs using the domain right here and the function. I want you to make a table and a graph for each of them. So construct those on your paper right now, and then we're going to move on. Okay, so now that you've done it, does number 1 look like this, where your table starts from -2 to 2, and you have those specific f of x values, and your graph looks like that with the label? And then does your number 2 look like that, where you have -2 to 2, and your y values or f of x values look like that? Make sure it's all neat and clear. If it's not, please correct your work. We're going to skip this page because this is going to happen in a classroom, not right now, remote learning. And we're going to go to this page. What I really like you guys to do is, using the 2 graphs that you just constructed, I want you to look at the table and then look at the graphs and make some observations. Describe the shape of the graph. Describe the direction of the graph. What do you notice about the tables? Is there anything that stood out? Are there any similarities in the equations? Are there any differences? And do you think this would be a growth or decay equation? These are things I want you to fill out and see if you get correct. Did you get these answers? Both are curved. The f of x 3 to the x increases from left to right. This one decreases from left to right. This one increases in the table for the y. This one decreases in the table. They both have 0, 1 is the same. They both have an x as the exponent, an exponential equation. This one has a base of 3. This one has a base of 1/3. And we would consider this growth because everything's increasing. And then this one's decay because everything's decreasing. So let's just summarize what we found out. When we have the equation f of x equals 3 to the x power, we notice the equation increased from left to right. Also, we notice that the values of y increased as we were increasing in the x values. When we switch to the decay formula, we notice that it was a fraction base, and the graph decreased from left to right. And so did the y values. They decreased from left to right. These are very important components that we need to take close notice of as we are discovering pieces about exponential growth and decay functions. What I'd like you to do now is look at the more mathematical ways. Exponential growth involves exponential increase of a quantity over time, which is represented by this function, where a is greater than 0 and b is greater than 1. That means a has to be any number greater than 0, but b definitely has to be a number greater than 1. That is going to tell us if it's an exponential growth. This number is greater than 1. Really, a doesn't matter as long as it's not negative. Or even here, like we have 2. 2 can be bigger than a fraction. As long as it's not negative, it's the base, this base that the exponent's being raised to. As long as that's bigger than 1, we're good to go for an exponential growth function. On the flip side, for an exponential decay, a has to be greater than 1. If it's negative, it flips it. So we're not talking about that right now. But b is between 0 and 1. b, the base, has to be a fraction for it to be a decay function. So b can be 0.5. Even if this number in front is a whole number, the base has to be a decimal. Same thing here. Your bases can be decimals. Even your a's can be decimals, but as long as your base